Back in 1903, workers digging a drainage ditch in Somerset, England yanked an ancient human skeleton from the dirt. It was 10,000 years old, almost whole, and when scientists finally mapped its DNA in 2018, they found something that completely stopped the field of anthropology right in its tracks. This guy, the oldest known British resident, now known as Cheddar Man, had dark brown to black skin and striking blue eyes. The mix seemed so incredibly weird to modern experts that they double-checked their results twice. But the DNA was absolutely clear. The earliest people of Britain did not look anything like the British folks of today. And that raises a huge question that turns out to have a pretty complex answer. How did human skin change from universally dark to the spectrum of colors we see today? And why did it even happen? Well, the answer doesn't start with race geography or even sunlight. It starts with a single molecule. Melanin is a pigment made by specialized cells called melanocytes, found in the deepest layer of your skin. Picture them as billions of microscopic shields, absorbing ultraviolet radiation before it can penetrate deeper and damage your DNA. The more melanin you have, the darker your skin is, and the more protected you are. For most mammals, fur does this job. It acts as a physical shield against ultraviolet radiation. Because of that, the skin under most animal fur is actually pretty pale. It doesn't need to produce tons of melanin since the fur is already blocking the sun, but humans eventually lost their coat. And the reason is directly tied to how we hunted. Around 2 million years ago, Homo erectus developed a clever hunting strategy called persistence hunting, chasing down prey not with speed, but with sheer endurance, running for hours under that blazing African sun. But thick fur, which was great at keeping warm, becomes a trap when you need to cool down fast. Hominins with less fur could sweat way more efficiently, hunt longer, and bring home more food. The ones with thick coats overheated and lost out. How that fur vanished over hundreds of thousands of generations is an incredible story in itself, but that is another video entirely. What really matters is what happened the very moment it vanished. Over hundreds of thousands of generations, fur disappeared. Skin was now directly exposed to the intense African sun for the first time. Without fur, melanin was their only shield left to protect them. So natural selection pushed hard in one direction. Melanocytes became more active, pumping out more melanin, and skin got darker. By the time modern Homo sapiens appeared, some 300,000 years ago, every single person there had dark melanin-packed skin. Not just some, but all of them. Dark skin was not a variation. It was the only thing that kept you alive under that brutal equatorial sun. This was the baseline, the default starting point for everything that followed. But melanin does something else too. Something that would become incredibly vital the moment humans started moving. Ultraviolet radiation does not just damage DNA. It also triggers a chemical reaction in our skin that makes vitamin D, a hormone that actually regulates calcium absorption, bone strength, immune system, health, and reproduction. And this is the exact hormone that would quietly rewrite the color of our skin forever. In equatorial Africa, this was never an issue. The sun was so intense that even very dark skin made enough vitamin D. Then, around 60,000 years ago, some of those dark-skinned Africans began migrating north. The climate was changing. Wetter seasons turned the Sahara into lush grasslands, creating natural pathways northward. Early humans followed those herds. As our population grew, scarcity of resources pushed younger groups into new territory. And this is where the physics became a huge problem. Up north, the sun sits low on the horizon. Sunlight travels through way more atmosphere before hitting the ground, filtering out most of the UVB needed for vitamin D synthesis. In winters that last 6 months or more, actual vitamin production drops to almost zero, no matter your skin color. Dark skin evolved to block 90% of UV radiation. In Africa, where UV levels are massive, that remaining 10% was plenty to make vitamin for everyone. But head up northern Europe where UV levels are only 10% of what Africa gets. And now dark skin lets in just 1% of that original light. That is not enough, not even close. Your body feels it immediately. Without enough UV exposure, vitamin D levels plummet to zero. Calcium absorption stops working properly. Bones that should be growing strong stay soft. Kids growing up here do not look sick at first. They eat and play seeming totally fine. But deep inside, their bones are growing completely wrong. This is where lack of vitamin D became more than a health issue. Evolution stepped in. Mothers without enough vitamin D had malformed pelvises and died in childbirth. Their dark skin genes died with them. But women with lighter skin, even a tiny bit, made just enough vitamin D to grow up healthy, give birth safely, and raise kids who passed down those genes. Generation after kicked in. Lighter skin survived, darker skin struggled. But the math never added up. If this filter ran every single generation, dark skin should have vanished from Northern Europe in a few hundred generations. But DNA evidence shows that as recently as 10,000 years ago, that's Cheddarman's era, most Europeans still had dark skin. For 35,000 years, that selection pressure existed, yet skin hardly changed. Why? The answer came from an unexpected place: their diet. Hunter-gatherers weren't relying solely on the sun for vitamin D. Fatty fish, animal livers, eggs, and sea mammals are loaded with natural vitamin D. A hunter-gatherer eating a diverse diet of meat and fish kept up their necessary vitamin D levels. Even with dark skin, even through dark northern winters, even without much direct sunlight, their skin pigment didn't need to change because their food did the work. Then farming came along and it changed everything. About 10,000 years ago, agriculture started spreading from the Near East into Europe, and that nutritional safety net vanished almost overnight. These early farmers weren't eating much fish and game anymore. They ate mostly wheat, barley, and simple grain porridge. But why the sudden change? Farming didn't just change what they ate, it changed how they lived. These early farmers were settled down, tied to crops that required non-stop work. But hunting and fishing take time, movement, and skill. Early farming communities were trapped in grueling seasonal cycles of planting and tending. Seasonal rhythms of planting and growing and harvesting. They just couldn't afford to spare people for multi-day hunting trips. Fish was a luxury for people near rivers and coasts. For inland farmers, their daily diet quickly became mostly grain-based out of necessity, not choice. And grain, no matter how much of it you eat, has virtually zero vitamin D. That single backup system that had allowed darker-skinned humans to survive in gloomy, low-light regions for tens of thousands of years was gone. Now, the natural selection pressure that had always existed became critical, with no dietary backup left. Vitamin D had to come from one single source, the sun, and it was weak. The only women who could produce enough UV rays were those with slightly lower melanin levels. Less melanin meant more UV soaked into the skin. More UV meant more vitamin D, and more vitamin meant bones and pelvises developed properly. These women survived. Their darker-skinned counterparts did not. And every surviving daughter inherited that same reduced melanin production from her mother. Over many generations, the population's melanin levels were slowly dropping. Human skin was growing lighter, not by choice, not by chance, but survival. But this shift required a catalyst. That slow pressure just wasn't enough to change an entire continent. It needed a single genetic mutation, powerful enough to speed up everything. And then it was a tiny copying error deep inside a cell in the SLC24A5 gene. Just one letter changed out of 3 billion in our human genome. This mutation reduced skin pigment production by 30 to 40%. One person living somewhere in the Middle East or Southern Europe was born with noticeably lighter skin than those around them, and it made them healthier. Within around 150 to 250 generations, somewhere between 3,000 to 5,000 years, That single mutation swept right through early European farming communities entirely, not because of culture preference or any conscious choice. It was simply that the people carrying this gene survived while the others slowly faded out over time. But here's the truly fascinating part. That very same genetic mutation, SLC24A5, is almost completely missing in East Asian populations. And yet East Asians also evolved lighter skin in northern latitudes. They just took another path. Those populations evolved lighter skin through entirely separate genetic mutations in completely different genes. Different molecular pathways, but the same biological result. Scientists call this convergent evolution. It is the same process that shaped dolphins and fish so similarly, even though they are completely unrelated species. The environment poses a challenge and evolution answers. Sometimes it hits on the same solution twice. This means light skin is not some one-time evolutionary fluke. It is a fix the human body independently came up with twice, driven by the same biological equation. Low UV, grains, vitamin D shortage, natural selection, genetic mutation, survival,